This is the second of the two videos for doctoral seminar for the VUS and PhD program around writing an analysis plan. And the first part had what's shown here in the outline as 1 and 2. And this is part 3, creating a code book. This is really about getting to know your data, and there's a little measurement theory thrown in here. And I realized after reviewing the slides from the first part and the slides from this part, this is really almost an entire research methods class crammed into about an hour. So I hope it's useful. So really what this is about is understanding the data that you have on hand, the data that you should choose to collect, and how you might collect it. This is a very funny little cartoon, which is in fact not facetious. These guys are talking to each other, and one of them says, "These data don't make any sense, so we'll have to resort to statistics." And this is a fundamental truth about statistical testing that we don't often talk about in our business, which is statistics are these very sort of technical and complex procedures that we bring to bear on data that we have gotten from a study that we've designed. We have hypotheses. We did all the things that we talked about yesterday. But in fact, sometimes things are so obvious that we don't need statistics, right? And so a scenario that I will often make reference to is a drug which improves cancer survival by 7 years or something. You actually don't need statistics to figure out that that's true. If the untreated group has a mean survival rate of 7 months and the treated group has a mean survival rate of 7 years, you don't need statistics for that. And I think that's something that people forget. That's about statistical stuff. This is more about getting to know and understand the variables in the data that you're going to have as you are designing a study and writing a proposal. So in both cases, right, the biggest job that you have to do, I think harder than choosing a design and a precursor to writing an analysis plan, is to really understand the data that you're going to have. We did talk about this in the first part when we talked about mapping the likely distributions and understanding the normative values in the population. This is, really about knowing your data, and that is 100% your job as the content scientist. So we're going to dive into that a little bit in this talk. So if you'll recall, our research question was about the effect of a mindfulness-based intervention compared to routine care in alcohol use disorder patients on the outcome of recovery. And we had a hypothesis about greater mindfulness being associated with better treatment response. Those are not bad. The research question is relatively well done in that it's framed as a PICO question, as we talked about in the other slides. But we have a few fluffy things here, right? The whole idea of the mindfulness-based intervention, we're not going to talk about. We're not going to talk about, routine care. Those are sort of outside the scope of an analysis plan, but those would be discussed in your approach section in general, right? You would describe the intervention in detail. You would describe the comparator of routine care. You would describe how adherence was being tracked. You would describe the number of sessions and how you were going to track, attrition or dropout or missed sessions, all of those things on the predictor side. We're really just going to sort of focus on, the statistical analysis in general. And we have some, as I said, sort of mushy things here. Mindfulness-based intervention, what is it? Routine care, what is it? What is recovery? That's sort of the most difficult one here. And how are we going to think about what alcohol use disorder patients are, who the population are? So even just in the articulation of a research question in a PICO format, we already have kind of some complicated things going on. This is just a slide that I like to show to kind of tee up thinking about measurement in general. We always, I think, are taught about design and analysis, and less often about measurement. One thing that is true about nursing science, and in large part because nursing science is sort of theoretically based in the same kinds of models as are used across sort of psychology and the behavioral sciences, is the importance of measurement, right? you guys do have a measurement course, and I am in fact a measurement scientist, but in other disciplines, I think they underestimate the importance of measurement. And so I just like to show this slide to remind us all that there are three pillars on which our inferences rest, and measurement is one of them. So really quickly, I'm just going to throw some sort of philosophy of science at you guys. You probably learned, if you came out of a nursing or psychology or social science background, that the definition of measurement was the assignment of numbers to objects and their properties. And the reason why this definition is taught in the social sciences is because it comes out of this whole sort of representationalist tradition that we're saddled with. I myself am what is called a measurement realist, and we're going to talk about that in a sec. The representationalist view comes from S.S. Stevens. He literally was the one who sort of teed this off for us as social scientists. And his definition was assignment of numerals to objects or events according to a rule. So that is sort of the historical and theoretical baggage that we are saddled with in the social sciences. And it's interesting to contrast that to the way they think of measurement in the physical sciences, which is the process of finding the length, size, or quantity, right, of what we're going to call an attribute, right, a physical quantity. Down in the bottom right, you see the quantification of attributes. This is an entirely different idea of what it means to measure. This is the idea that is predominant in the physical sciences, and this is the idea that's embodied in a philosophic paradigm called measurement realism. And so, you're going to hear me talk from a realist perspective, and I thought I should sort of let you guys know that to the extent that some things that I say are different than you're used to thinking about them, they're because I'm a measurement realist. And when you take the measurement course, whether you take it with me or someone else, you hopefully will get to learn about the difference between those approaches. We use the word operationalize. That does come from this other sort of social science representationalist standpoint, but we're going to still use it. We're going to sort of mix the language up a little bit so that we all understand. So when we talk about operationalization, what we're talking about is choosing how to measure the things that we're interested in. So mindfulness and recovery are both unobservable phenomenon. From a realist perspective, we like to just call those variables, right? We assume they're real things. We assume that they have properties that we might be interested in measuring, like the amount of. But if you want to call them constructs, which is sort of what comes out of the social sciences, you can also feel comfortable calling them constructs. I don't necessarily call them constructs. But the idea is that we have these mushy concepts that we need to make decisions about how we're going to measure them. So I'll just remind you that from the realist perspective, and some of this sort of creeps into teaching in the social sciences, when we talk about what kind of variables are there. As a realist, we say the variables are the real things that we're interested in, right? They're the traits or attributes or properties of the things we're interested in, these concepts that we're interested in our case, mindfulness and recovery, but also things like speed or days in the hospital or BMI. And there are only two kinds of variables in the world, right? And what we're really saying here is we're saying there's only two ways that these features or traits or attributes can exist. We're not talking about our measurement of them. We're talking about how they really exist in the world. And those are two separate things. Our measurements are our attempts to get as close to a perfect measure as we can, and we often fall short. But our measurements might fall short as they're human endeavors, right? But in terms of the way things really are in the world, there are only two kinds of variables. There are those that exist in categories only, and those are called discrete variables. And dichotomous variables are a special kind of discrete variable with only two categories. So the example that's often given is living and dead, which is pretty unambiguous, right? A person, a biological person, an entity, an animal is either living or dead. And the most commonly used discrete variable for us in our business is like what group are participants in. I'm going to just kind of stall a little bit here to say there's some ambiguity, right, in things like sex. And there's sort of this circular reasoning, right? If you think about the reality of biologic sex. Well, does it depend on how you assess it, right? If you assess it via the presence of different gametes, right? An organism has sperm or ova versus an assessment of DNA versus an assessment of physical characteristics, you might arrive at different conclusions. Measurement theory is a really complex and sort of ever-evolving field of study that I love to talk about, but we're just going to talk about now. Even though some things might be difficult to get as precise a measure as possible, and the difficulty lies in everyone agreeing on the measurement tool. In any case, we still think that there are these phenomenon which can have these characteristics, and that those characteristics are either that the phenomenon are discrete, or that they are continuous, which we're going to talk about in a sec. But before we leave discrete, let's think about the kinds of roles that variables can play. Discrete variables can be a predictor variable. So a quick example is just, a treatment group being associated with lower values on some outcome. Discrete variables can also be an outcome variable, right? If you think about trying to predict baseline BM or trying to predict program completion on the basis of some continuous measure of BMI, then we're using a continuous predictor variable and a discrete or dichotomous outcome. Did they complete or not? These are all just examples of how you might think about the roles that variables can play in your study, because when we put our codebook together, we're going to make explicit in our codebook what the role of all of these variables are. And so that's why we're sort of stalling here for a sec. Okay, so continuous variables are those variables, and I'm also saying attributes, traits, phenomena, whatever they are, constructs perhaps, that whose nature is that they exist in the real world on a number line. And the easiest way, and if you just memorize this, you'll never forget, right? The way to think about what makes an attribute continuous is, in some hypothetical scenario, if you had a perfectly precise measurement device and an infinite number of samples, would the measurements that you could obtain, the infinite number of measures with your infinitely precise device, would they lie on a number line? And if the answer to that is yes, then the nature of that variable, phenomenon, attribute, whatever it is continuous. If the answer to that is no, then you have a discrete variable. Okay. Continuous variables also can be either predictors or outcomes. That should be pretty straightforward. The reason we stall on this is because I think from the learning of statistics, the thing that trips students up, right, is what kind of test do I need? Which test do I need here? And the answer to the test that you need is always predicated on the kinds of variables that you have. If you have a continuous predictor variable and a continuous outcome variable, like is college GPA associated with, in this case, MCAT scores, then the test is driven by continuous predictor, continuous outcome. In that case, you can either do a correlation or a regression if it's really sort of set up as a predictive association like this one. Continuous variables can act as outcome variables. So we're talking here about program completion being associated with some continuous variable. You've got a discrete predictor, right? They completed or not, and a continuous outcome. And the thing it makes most sense to ask here is about the mean difference in the continuous outcome by group. And that would be an independent group's t-test. The examples on the previous slide, right, where we talked about, we might have a discrete predictor or a discrete outcome. The answer to the question of what test should I use is given by what kind of variables do you have. And that I think is just a little nuance that sometimes we forget. If you can phrase the question, your research question as, what kind of a predictor do I have? What kind of an outcome do I have? Then you can go to Google and ask it which statistical test you need. Okay, so let's again just revisit this idea of, all right, we've got these variables that are either continuous or they're discrete, and we know what role they're going to play in our study design. Now we're going to talk about how to measure them. So measurement should be, in this realist perspective, an attempt to get as close as possible to the actual true score. We don't ever have an infinitely precise measurement device, right? Even if the thing we're interested in is an interventional study that's supposed to impact BMI, we're probably going to accept BMI as measured by pretty imprecise measures of height and weight, right? To how many significant figures do you need height and weight to get an accurate measure of BMI? There is some true measure of BMI, right, out to some infinite number of decimal places, but we almost never need that, right? And so what we're doing is we're saying, well, I'll settle for a certain amount of imprecision. When we teach students this levels of measurement thing, it's often poorly taught as if the levels of measurement are something real about the variables themselves, but they're not. Variables are either continuous or discrete. And I think it's easier then to think of the levels of measurement issue as how close did we get to the ideal measurement? So I'm sure you guys remember this levels of measurement stuff from some other course. Nominal is an assessment or a measurement of, right, a discrete variable, where all we're doing is assigning names, right? That's what nominal means. Ordinal is a level of measurement that probably also describes a discrete variable, right? Where we're sort of ranking these categories of discrete things. And interval and ratio describe a level of measurement that we got to, like how well we did getting to a true measure of a continuous variable. Okay, if you also recall, from the slide where we talked about our study design for this mindfulness-based intervention in alcohol use disorder patients on treatment response, we had a big list of questions that we could ask, and I probably didn't land firmly on one or another, but really the best question to ask in that kind of a study design where you have a pre-intervention, post-intervention, and then a follow-up time point, the question that we really want to ask is about the rate of change, right? Whether the rate of change is different between the groups. And I spent a lot of time in that last talk making a big deal out of how that's a different research question than is there a statistically significant difference between the groups post-treatment at time point 1 and at time point 2, which are also fine research questions. And the nuance about why you would ask, one set of those versus another is not, we're not going to undertake that in this talk. Just know that sort of what I'm teeing up here is this choice of, is there a statistically significant difference in the rate of change over time between the groups? So let's talk about the two sort of difficult things we have to operationalize in the study, and those are mindfulness and treatment response or recovery. When you take the measurement course, you'll learn all about how to choose a good scale, right? What does it mean for something to be validated, how you choose it. But that is an act of operationalization. We're just going to assume for the purposes of this short talk that we have decided that the 5 facets of mindfulness scale, the FFMS, which is a real scale, is the best one, and that we chose it from a literature review. Treatment response or recovery, I did actually do some searching in the literature to make this decision. This is a operationalization of a variable that is based on a theoretical framework about change, right? So this is like the Prochaska assessment of readiness to change, right? Where people can be assigned a number from 0 to 7 about what their where they are on their change from being an alcohol use disordered individual. And those levels are pre-engagement, engagement, early persuasion, early active treatment, late active treatment, relapse prevention, or full recovery. So this is a 0 to 8 measure. I'm not going to call it a scale. It's not a scale. A scale is an individual collection of items that all measure the same thing. This is probably best described as an index. So these were both chosen on the basis of my knowledge of this research area, which I have none actually, because this is just an example. But what you would do is go to the literature and make these decisions. All the while understanding that mindfulness, I believe, is a continuously distributed phenomenon, right? It exists in the world, in my best guess, right, as a measurement realist. I think this is probably a continuously distributed phenomenon like height or weight or speed. But my options for assessing it or measuring it are, I have to choose a scale, and I'm going to treat the numbers that I derive from that scale as coming from and being, numbers that represent a continuous phenomenon. Am I going to do the same thing with this 0 to 8 assessment that I have of recovery? I am. What are my other choices? So this is where things get tricky about, is this, a continuous variable or not? And and that would, bear significantly on the question of the kinds of analysis I can do, because this is my outcome variable. The best advice I can give you is, right, remember that there are only two kinds of phenomenon, there are only two kinds of variables. It doesn't matter if your measure of that phenomenon doesn't look continuous. What you're doing is getting as close as you can to the best measure of the continuous phenomenon as you can. And we may have made this decision on the basis of what we think, represents an adequate response to a treatment for alcohol use disorder, right? I want to really know if people are in recovery or not. But could I have chosen, number of drinks per week, perhaps? Or there's probably a self-report measure out there that lets people with an alcohol use disorder talk about, their level of addiction or recovery or use, right? A number of ways we could have approached this. All the while thinking, and this is why it's terrifically important to make sure you even are using the right words or articulating this well. The research question and the PICO had the idea of recovery in it, right? That's what the investigators in the study are interested in, recovery, not drinks per week, right? That is the key there in choosing the way you're going to operationalize this. If the researchers had come maybe to me as the statistician and said, we don't care if people are in recovery, right? We don't believe in recovery. That's an outdated model, whatever. I just need to know that they're drinking less, right? Then I might have asked for a self-report measure of use. Or, if this were a large enough RCT with enough budget, I could have people come in and I could have them do a blood alcohol, a breathalyzer or a blood test, right? Which would give me a much more accurate measure of a different phenomenon, right? That phenomenon of use. What we are trying to assess here is not alcohol use, it is recovery. And it is your job to think really carefully about that when you design your study. All right, I hope we spent enough time on this slide for you to really sort of think through and appreciate the importance of these kinds of decisions. And this is why, when we talk about the three pillars of scientific inquiry or inference, one of them is measurement. Measurement is an incredibly important and subtle thing that we have to undertake when we think about designing a study. Okay, so quickly. Now we have to think about what other variables we want to collect in our study. This isn't a randomized control trial, this is an RCT. And in RCT, you have an independent variable, a dependent variable, and then sometimes you might be interested in some covariates. Covariates are defined as variables that you could measure in your study that are related to the outcome only. They cannot be related to the independent variable. And their inclusion increases the power to detect effects. And hopefully the picture makes it somewhat clear why that's true. A covariate will subtract some of the variability in the outcome variable out, right? Subtracts covariance or shares covariance with the outcome variable. And it allows the treatment variable to have to account for more variability. That is the definition of a covariate. Since this is an RCT, this hypothetical study, we might want to choose some covariates, and we'll talk about that in a sec. I want to contrast that with a confound. A confounding variable comes from a quasi-experimental setting or quasi-experimental design. A confound variable is a variable that you could measure that's related to both the outcome, but also to the independent variable or the grouping variable. This is, I think, a often misunderstood distinction. Covariates are good things. Covariates allow greater power to detect treatment effects. Confounds are bad things. Confounds don't allow us to make clear inferences about the effects of treatments because the outcomes are confounded. And this is the difference, or these arise from the traditions of randomization or RCTs versus quasi-experimental or observational studies. So in our study, we want to choose a covariate. And how are we going to choose a covariate? Well, now we know, right? The way to choose it is to choose a variable that could be related to treatment response or your outcome, your dependent variable in the study. That's how we choose covariates. That's just in a nutshell. Of course, that's a simplification, but that's step one. And then you also always are going to collect some other variables to descriptively characterize the sample. So we call those demographics. How many variables do you need? Well, it depends on how big your study is, how large your sample is, how much money you've got. A handful is a good answer, right? There's generally 5 to 7 demographic variables, depending on the sample size, anywhere from 1 to 5 covariates, right? Those are just rules of thumb. Okay, so what I've got here is a code book. You must have a code book before you go to your statistician. It's not your statistician's job to create a code book. This is just an Excel file that shows the name of the variable, a short description of it, what kind of variable it is, what the items are called. This comes obviously from SPSS. What the response options are. So you see the first row is the variable time. Right, I'm going to need to measure some time points because I've got 3 of them. That's a discrete variable. It's got 3 possibilities, right? Baseline, post-intervention, and follow-up. It ranges from 0 to 2, and in that column on the right called role, I've got an A in there for analysis. Right, that's an analytic variable. The next variable I've got is age. Age is, we're going to descriptively characterize the sample. Is it possible age could be a covariate? Is it possible age might be related to treatment response? Sure, it is. We don't necessarily, well, we would know that from the literature. In the role, I have it down as descriptive, but it's also potentially a covariate. The variable, the next row is previous treatment, number of times the person's been in inpatient treatment for alcohol use before. And I have that described as a covariate. That was the covariate of choice here, right? I know I'm going to collect this because I know that it's related to treatment response. And here's the options, right? It's 0, 1, 2, 3, 4, or 5 or more actual times that they have been in previous inpatient treatment. But I might want to rescale that as ever or not, right? 0 or 1. These decisions are decisions that these are tough decisions to make, and you make them based on your knowledge of the literature in collaboration with your statistician, but also to the extent possible, you should try to have something looking like this code book put together before you collaborate with your statistician. I'm choosing to measure number of children, relationship status, those are descriptive or demographic variables. Here's the substance abuse treatment scale. This is very interesting to think about because in some sense, right, when I descriptively characterize this sample, I'm going to want to talk about where they were pre-treatment, just as a group, and then where they were post-treatment, and I'm probably going to want to talk about by groups separately to establish that pre-treatment, we hope, right, everyone was on average at the same place, but post-treatment that the groups differ. So this is actually a difference variable, right? I'm going to be subtracting to create this variable, and I have to think really carefully about what the resulting numbers mean. If a person is, because in this particular case, higher numbers are better, right? The higher the number, the more recovery a person has. But think about what that means if you do a subtraction. If a person is at early persuasion pre-treatment, they're at number 2, and they're at relapse prevention post-treatment, that's a good thing. But I'm subtracting, right? 2 minus 6. I get a negative number, don't I? This particular variable is scaled so that negative numbers are better. Negative numbers indicate improvement. You just absolutely must be thinking about those kinds of things, right? What do my numbers mean? And that's when we talk about getting to know your data. How are we going to operationalize these phenomenon? Right? This is sort of the level of detail. The 5 facets of mindfulness happens to be a measure that has 5 subscales that are, I forget exactly what they are, like non-judgmentalist, non-reactivity, but then it also has a total score. And so, right, one of the columns here that we haven't talked about yet is range. What is the range of values that it's possible to achieve on these variables? What are the response options? What are the items called? This is an adequate code book for the study that we've been talking about, the hypothetical study. All right, so now we can write our analysis plan. And this is what I said at the beginning of the first part of this talk, which is this is the easy part, right? Once you get all the way down here, then you come to your statistician and say, oh, I've got a discrete group-based predictor variable in a randomized control trial, right? And a continuous outcome that's measured such that negative numbers are better, right? This is the sort of thing that now you're ready to write your analysis plan. You've done all of the hard work already, right? That was the hard work. All of this other stuff was the hard work. Remember what I said, all analysis plans have the same general format. You talk about your variables, what role they play in the study, and then in the analysis plan, you talk about screening the data, looking for missingness, computing descriptive statistics. And when I say for the sample as a whole and for the groups, if applicable, in this case, you would, right? You would demographically characterize the sample on all of your descriptive demographic variables. Then you would look at the groups separately on those same variables because you want to establish that randomization was successful. Same thing for the mindfulness measure, right? Pre-treatment, you want to see no difference between the groups in mindfulness. These are just descriptive statistics. Probably it would be reasonable to try to go to the literature and look for normative values on the mindfulness measure in both normal, I'm doing air quotes, normal populations and possibly in alcohol use disorder populations. Same thing for that treatment response or recovery variable, right? It would be interesting to go to the literature and look and see if you sample a group of alcohol use disorder patients out of the population of alcohol use disorder patients that theoretically exists out there, and look at the average level of recovery that they're at. What would you find? How does your sample compare to that? And then talk about that in your, in your analysis plan that you're going to do that. Why are you going to do that? It's helping you characterize your sample, right? Who did I get for this study? How do they compare to all of the alcohol use disorder patients that are out there? And then we're going to make a giant table of all the variable interrelationships. And we're going to do that to do covariate identification. Covariate identification is, as I said, a subtle and tricky topic. Better to have identified covariates ahead of time? Probably, yeah. Identify them from the literature, from your knowledge of this research area, from your conceptual model. But it's not awful to do it after the fact, too. If it turns out that I didn't know age was going to be related, but it is, it's fine. I'm going to use it as a covariate. This process also lets you identify whether or not your predictors are collinear. That really applies more in the context of like multiple regression. And now the hypothesis. So this is the part that people, learners or trainees, are worried about, right? Writing the analysis plan, hypothesis testing for the aims. And our aim, as we concluded, was going to be like, is there differential rate of change between the groups? You don't have to worry. You don't have to know the answer to the question of what analysis do I need for that, but you have to know the answer to the questions of all of the questions before that. And that has been the point of both parts of this talk, was to say it's the other stuff that we have to do as the content scientists. Once you get to this part, right? Yeah, come to your statistician. That's what we're here for. Okay, so a few references at the end of these slides. This wonderful free book that you can find online by Gopal Kanji. It's called 100 Statistical Tests. Just Google it. The G-Power software is a free software package you can get for power analyses. The VUMC has biostats clinics every week, twice. You could just go sit in on those and listen. There are opportunities for faculty and learners to come to the VUMC biostatisticians and ask questions. They're just fascinating to go and listen to. And my hero, John Unites, this is from PLOS Medicine in 2005. He is a meta researcher who talks about a lot of the sort of pitfalls in doing science well and how difficult it is. Okay, it was a pleasure talking to you guys, and I will see you all soon.